Okay, we are going to look at composition of functions in this lesson. I'm actually going to break it into two parts, and this is the first part of that lesson. First of all, what a composite function is a substitution of a function into a function. So rather than just putting a numerical value in, you're actually putting an entire function in. We could say the input of a function comes from the output of another function. Here's an example with a function f root x and g x plus 1. I can say that, let me grab a pen, that g of 3 is the substitution of the number 3 into the function g and produces the result 4. I can also say that f of 4 is the substitution of the number 4 into the square root function, producing 2. Now, what this tells us is that the function f with the function g with the value 3 substituted equals 2. What I've done again is I've substituted the number 3 into the function g, got the result of that, and that became an input in the function f. This can also be written using another notation with a little circle, not quite as big as an O, f of g of x, or with the brackets. Both notational forms mean the same thing. Now, excuse me, when it comes to how to do this, what we're doing is a substitution of an x value, or domain, into the function g, and then a substitution of the result of g of x that we just got into the function f of x. So this is what a composition is. Now, something we need to discuss related to this is something called a domain restriction. And the function f of g of x, or f of g of x, written whichever notational we want, I shouldn't say has, let me say the domain restriction of this is the restriction contributions of both f of x and g of x. And we'll look at what that looks like by using a couple of examples here. So first up, example 1, I'm going to give you some functions. F of x is x squared minus 1, and g of x is the root of x minus 3. And what we're going to do is determine what f of g of x would be, as well as what g of f of x would be. So the first one, we're taking the function g, putting it into the function f. In the second case, we're taking the function f, putting it into the function g. Pause the video, try it out, come up with results, and see if your results are the same or different. Okay, hopefully you've paused and you're ready to compare your work. So the function f has the structure of something squared minus 1. If you look up here, x squared minus 1 means something is squared minus 1. What's being substituted is the function g. So I take the function g and it goes in the place where I used to have an x. Now let's contrast that with the function g of f of x. G of f of x begins with the square root of something minus 3. What's put into the something is the function f of x. So you can see we've done something different in each case. Now, simplifying this result in part A, the square of a square root are inverses, which cancel, leaving me with x minus 4. While in this part B example, I've actually got x squared minus 4 in a square root. So different results depending on what gets substituted in what place. Now, if we consider the domain of these, in this first case, the domain of the function g is x has to be greater than or equal to 3. I know I can't take the square root of negatives, so what I put in the function g up here has to be 3 or more. All right? Now, looking at the result, f of g of x, it has itself no restriction on the domain, and so the restriction on the entire function is x greater than equal 3 for the domain of part A, f of g of x. If I look at the right one, the function f of x itself has no restriction. If I take something and square it and subtract 1, I can do that with any value I like, positive, negative, large, small, whatever. So the function f has no domain restriction. The function g with f put in it, however, does have a restriction because, again, we can't take the square root of negative values. So we know that x squared minus 4 itself has to be greater than or equal to 0. So x squared has to be greater than or equal to 4, and you may recall from pre-calc 11 this was a little bit of a tricky thing. Inequalities with quadratics, what we actually say is that the absolute value of x itself has to be greater than or equal to 2. Another way to say that is x is less than negative 2, or x is greater than or equal to positive 2. And you may want to think about that a little bit, try substituting a few values up here at x squared greater than 4 to see that this is the case. That's the first example. Now another example. Some new functions. You're told that f of x in this case is 1 over x plus 1. You're told that g of x is the root of x minus 1, and we want to find the value of f of g of 5. Now I'm going to work this problem out two different ways. Why don't you pause and make an attempt and see how you do, and then compare with the results that I have. Okay. The first method that I could use is I could try to determine what f of g of x is. F of g of x is the function 1 over something plus 1, and the something is the function g. So I substitute that. There's f of g of x. Now, I could remove the bracket, but it doesn't really make it any simpler. F of g of 5 then is substituting the value 5 for x in the function I just wrote. And I end up with 1 over the root of 4 add 1, which is 1/3. Now there's another way to do this problem. Because I was given a numerical value for the input rather than generally x, which wasn't defined, I could do this. I could find g of 5, because that's what it says inside there, g of 5. And it says g of 5 is substituted into f. So let's look at that. G of 5 is the root of 5 minus 1, which is the root of 4, or the number 2. So g of 5 is 2. Looking at the question, we were asked, what is f of g of 5? F of g of 5 is the same thing as f of 2, because g of 5 gave the result 2. So what's f of 2? It's 1 over the substitution of 2 into the function f, which is also 1/3, a different way to do the problem. Now the benefit of part A is that, at least at the first line, I created a new function of x that could be solved for different x values. And then I substituted. But I had to do algebraic work. And this one wasn't bad. They could get worse. In B, the benefit is that I substituted and had numerical values to work with right away, which was easier. Problem is, if I had to find f of g of 4, for example, I'd have to start over from scratch. One more example to do in this lesson, and it's similar to what we've just done, but somewhat more challenging. I want to find, given this f and this g, my goal is to get f of g of x, for one thing, and for another, g of f of x. Okay? Good opportunity for you to pause, try these out, see how you do. Okay, we're back, and I'm substituting g into f. The function f is 1 over something minus 2. The thing being substituted is that rational expression. Now, this is a compound fraction, and the easiest way to deal with it is to multiply everything by that LCD, x and 1. So I'm multiplying x and 1 on the numerator, and I get x and 1. When I multiply this x and 1 onto the denominator, it will cancel on this term, leaving just the x minus 1 numerator, and then I have to multiply the 2 by that value as well. Simplify, getting x plus 1, and then I have denominator of x minus 2x, so negative x, and negative 1 minus 2, or negative 3. Okay, now I should talk about the domain of this one. The domain of f of g of x depends on the domain of g, and g has domain all values except negative 1. F of g, for various x values, has a domain of everything except 3. X can't equal 3. So my entire domain is everything except negative 1 and 3. So I can say x is all reals without being equal to negative 1 or 3. Part B, let's go back. Now I want to put the function f into g. Okay, the function g looks like this, and I want to put the function f inside of that, looks like this. I have a common denominator of x minus 2. So, multiplying the numerator, I'm going to get 1 minus and x minus 2. Multiplying the denominator, I'm going to get 1 plus x minus 2. And simplifying gives negative x plus 3 over x minus 1. The domain this time is based on f, because f was substituted in. X can't be 2. And looking at g of f, x can't be 1. All right, that's the first part of this, and that should let you get through a number of the questions on this topic. And there's a second part coming up.